Okay, everyone. So, welcome to the latest in this series of webinars from Sigma-HSE. I'm encouraged by the number of attendees at the moment because this particular presentation has probably the driest title of any I've ever given. It doesn't sound terribly inspiring, does it? But I shall try to make it as lively as possible. With that in mind, I'll just quickly run through my contractual obligations of introducing myself and telling you a little bit about how I'm going to approach this and how I hope to be able to help you. So my name is Mark Bunch, and I'm a principal consultant for Sigma-HSE. My background is I was originally a chemical engineer throughout the 1990s, and then in the late 1990s, when COMAH first sort of came onto the scene, my boss asked me, "What do you know about COMAH?" And I said, "Well, nothing." He said, "Well, Google it and then apply for this job we got going." I was working for BP at the time, and we formed a little team, and together we wrote some of the first COMAH safety reports in the country, and we did them for Baglan Bay in Wales, we did them for Grangemouth in Scotland, and BP Chemicals at Saltend as well. So that was my first foray into the legislation. It's changed a little since then, but the basic principles remain the same. I work for Sigma-HSE. We're a consultancy, a process safety consultancy, and we're getting around now. We're based in Europe, and headquarters are in Winchester in the UK, down south. I'm based up north. We have offices out in New Delhi and Hyderabad in India, and a recent opening of an office in North America as well. So we're growing. And the kind of things that we get involved with, really, it's three prongs. Consultancy, which is where I spend most of my time. We have testing laboratories, and a few weeks ago I went down to see them. And they're very impressive, and they're run by people who are far cleverer than I am. But there's all sorts of testing they do, mostly around the desir work, but we also have reaction calorimetry as well. So we can help clients, as well as defining their explosive and fire potential, to have a look at things like runaway reactions and other such really clever stuff that I've forgotten all about now. On the consultancy side, it's process safety management, so lots of hazard studies, and that's really where I spend most of my time, things like HAZOP, hazard, those kind of things. But on the back of that, there's an awful lot of training that we offer. This is, I suppose, one small example of the kind of thing that we're able to do for you. The laboratories that I mentioned, so I talked about the chemical reaction hazard testing, thermal stability, explosive properties, gas and vapor properties, and electrostatics as well. It's completely over my head. I understand very little of it, but the reports are nice. This is where I spend my time, though. Consultancy, process safety management, implementation and review, desir and ATEX assessments, functional safety, we do some of that as well. Reaction hazards and consequence analysis from those, and the mainstay of process safety management, the hazard identification and risk assessment side of it as well. So we do all of that. But today we're going to talk about COMAH, the key control of major accident hazards regulations. And I've split this up as best I can into where I think I've had the most questions. We've helped a lot of companies over the years, and a lot of them have been COMAH sites to one extent or another, i.e. either non-COMAH, lower tier, or upper tier. And it makes a difference because the duties under those different sets of the regulations differ. So I wanted to cover a little bit about COMAH and its background, and that's the scope and alignment section, how we came about having the regulations, how Seveso directive from the EU plays into that, and then the details of it. So what you are required to do under a major accident prevention policy, what your safety management system should cover, and then the demonstration that you've got the residual risk or the risk that you retain on site under a reasonable amount of control, by which I mean as low as reasonably practicable, the so-called ALARP principle, which is a legal framework within the UK. And then this last bit, what we've termed as regulation to reality, and that's the difference really between what the law says you need to do, the regulations, and what you actually do, and what an inspector or somebody reading your COMAH report is going to look for. And that is, do you demonstrate that everything you've said you do actually do? So there's going to be some keywords that I think you're going to get very bored of me saying. And one of them is going to be demonstration, because that really is key. You can't take credit for having a safety management system in place if you cannot demonstrate that it works. And that filters down throughout the control measures that you have. You can have them, you went out and bought them and paid for them, but if you don't look after them, if you don't demonstrate that they're there and that they do the job that you require them to do, then you are unable to take credit, and you will find that the residual risk is no longer a LARP, and that you're required to do something about it. So that's how I've split it up. Demonstration is going to be a key word, and documentation as well. I think that's going to be another one that you get thoroughly fed up with my saying. I shouldn't start with an apology, but I'm going to. In fact, two. One is that the slides are full of words, and that's an unfortunate side effect of talking about the law. However, what I've tried to do is, where I've got particular examples from clients that we've seen in the past of particular failures about what I'm talking about, I'll try and highlight them. It kind of makes it a little bit more interesting, a little bit more real for you, and hopefully it'll make the time pass a little bit quicker. The other apology is that, well, you're not to know this, but just before we started, I sat on my reading glasses, and I'm currently swapping between two old pairs. So if I misspeak, I apologize for that, and you can blame my poor eyesight. It happens to us all as we get older. So, into the first of these sections. So this is the scope and alignment section. So what COMAH covers, how you decide whether you're in the COMAH club or not, and how it relates to things like the Seveso directive. So if I can just click on here, I should be able to get a laser pointer. There we go. You can see what I'm talking about now. So there are a number, and quite a substantial number, of establishments across the UK which fall under the COMAH regulation. COMAH is concerned with, and it's in the title, the major accident hazards, the fires, the explosions, and the toxic releases. These are the things that get you in the paper, get you in the news, and can do not only serious damage to you as a company, but to people, the environment as well. I've said major accidents. These are relatively low frequency. We don't have them terribly often. And it's one of the features that when we do have them, if it's been 20 years since the last one, they tend to be noticed, and they tend to produce changes in legislation. So it's specifically low frequency, high consequence events, and high frequency or relatively low consequence events, because those are the ones that are going to give you the biggest risk. Risk being the combination of likelihood or frequency and the consequence that goes with those. Tested, not theoretical. So it's proven. It has to be demonstrated. There's that word. It's going to come up again. And you are inspected. And this report is read by people who go through it with a fine tooth comb and look for demonstration and evidence that you are doing what you say you are. You cannot take credit unless you are. And active enforcement as well. So the competent authority, and in this case we're going to be talking about the Health and Safety Executive and the Environment Agency, can prohibit operation where you are not demonstrating that your risks are as low as reasonably practicable, or where you are not doing the things that you say that you are doing. So the regulatory, I've called this architecture, which is a grand word. We have COMAH 2015 now. This is our legal framework. It is the UK's implementation of the original Seveso directive. So there are two frameworks, it's true, but they share a common structure. And I shall say a little bit about how Brexit played into this without upsetting or treading on too many people's toes, I hope. Be entirely factual. There is a joint competent authority. I mentioned this, the HSE, slightly different for nuclear sites, working alongside the Environment Agency and their counterparts in Scotland and Wales. And there is oversight over those as well through the Competent Authority Strategic Management Group, who must be like a set of mafia dons sitting in a garret somewhere. And they essentially police the police, make sure that the enforcement approach is consistent nationally. And that's important because if it weren't, then that is a contribution to overall risk as well. So that's the regulatory architecture that sits behind it. How do the scope and the requirements of the Seveso directive correspond to one another? So mainly through who qualifies to be in the COMAH club. So we've separated this out into things like thresholds for substances, under named substances and types of substances. That aligns with the Seveso directive. The other legislation that changed along with it in the EU is the CLP, which is the classification, labelling and packaging regulations. So there is now a commonality of language between those and across the European Union as well. So we'll say about the difference between upper and lower tiers and whether there's been any noticeable divergence since Brexit. So what triggers COMAH is, first of all, Regulation 3, and that needs to be taken along with Schedule 1. So you'll find these in the regulations, but essentially Regulation 3 tells you what is the establishment that is covered by these regulations. Some aren't. For example, some of the nuclear processing is handled by different sets of regulations. But if you decide that your establishment does fall under Regulation 3, then the next thing to do is to look at Schedule 1, which will tell you which substances get you into the various tiers and whether you qualify or not. There are two thresholds. There's an upper tier and a lower tier, and it's based entirely upon the amount that you have. It is broader, however, than just chemicals. Storage, distribution, or chemical processing, I should say. It's the storage, it's the distribution, explosive counts as well. And some, we've termed these nuclear adjacent activities, if the quantities qualify. So it's not simply limited to traditional chemical processing and the manufacture of chemicals. And the test is about the quantity that is held on site at any one time, not your average annual throughput or just an average inventory that you've got. You can be tipped into the COMAH club simply from having a delivery you weren't expecting. So you've got to take a realistic view as to what your actual inventory is on site. But that is what the trigger is. And there are now two routes to describe to you. One is based on the CLP classification, and one is based on named substances. So this bit's easy. You can go and look in Schedule 1. There's a list of substances there together with the two threshold values. And sometimes it isn't the substance itself, but the type of substance or the category of substance. And this is where CLP comes in. Because you then have, for example, an inventory of smaller quantities that together, when added up under the aggregation rules, tip you into being COMAH or not. Form takes, you need to think about the way you handle stuff. For example, nickel is, as an ingot, the worst you can do is drop it on your foot. If you have it in an inhalable dust form, then it's toxic, and you need to pay attention to that. And also mixtures, which are assessed on the classified properties of the mixture itself, and not simply the sum of the component thresholds as well. So aggregation becomes important. You can group and sum these under the CLP guidance for categories, and bear in mind that there is a calculation to do here, this summation calculation, which you will find in the regs, added proportionally and not counted in isolation. So you can cross a threshold through any combination, even if no single substance does so alone. And we've seen in the past a common review fair that people didn't think they were in the COMAH club because of these aggregation rules. So once you've decided that you're either lower tier or upper tier, the duties are significantly different, really. The core duties are the same, in that you're trying to limit the potential for having a major accident. Core duties for lower tier sites, first of all, to notify the competent authority. So there is a requirement under Regulation 6, and that means sending them a letter, having a meeting sometimes as well. To prepare and maintain a MAPP, or a major accident prevention policy, which is quite high level. I'll say a little bit about what it should include, but it's relatively short. You are under an obligation to provide the public with information, what to do in the event of a release, for example. Cooperate on domino sharing information as well. So you may have neighbours who don't know what you're doing, and if you can affect them by having a major accident, or fire or explosion or something, there is a duty upon you to share that information with, and likewise get any information from them about any harm that they can do to you. So the upper tier duties, everything that I've just mentioned, plus produce and submit a safety report, an on-site emergency plan, cooperate in testing of the off-site emergency plan, and subject yourselves to more frequent and more detailed competent authority inspections. So that all looks fairly short, but this bit, produce and submit a safety report, that's the killer. That's what's going to take up your time. That's what's going to take up a lot of your resource as well. And it is the safety report on which you are judged in combination with the inspections and so on. But many companies now are into the COMAH's been going a while, and a resubmission is required every 5 years or so. So we've had 5 cycles since the regs came into force. So most companies now have a pretty good safety report, and it's really only the changes that they need to resubmit from time to time. So for Seveso 3, this was the legislation that COMAH is our implementation of. These were its core principles, having a common baseline sitting underneath everything, so that everybody was similarly treated and met similar standards. The CLP regulations, I've already mentioned that this alignment exercise, it was part of its intent. Greater rights for the public to know what is in their backyard, as it were, what their neighbours were up to, and the duties under the domino effect as well. And that's that telling your neighbours what you're up to, so that you can find out how they can hurt you as well. So just to align the two, for COMAH and Seveso 3, our implementation, they're nearly identical structurally. So there is the same tiering logic, the same requirement for the MAPP, for the safety report, and the safety management system. Those are pretty much the same, but that's part of the structure. So for the Great Britain's transposition of Seveso 3, I've said here, it's COMAH is the operative text. It is simply the implementation of the Seveso 3 directive. Varies for different EU operators. It's transposed into their own national law, but that structure must be as near as damn it structurally identical. And for groups who run perhaps European operations as well as UK regulations as well, it's going to be the local laws that take precedence. So that needs to be borne in mind if you've got operations outside the country as well. Post-Brexit, there hasn't been much in the way of divergence, although we are independent as far as the development of the law goes. We've retained it. I've said retained but independent here. There isn't therefore an automatic flow through of any changes that were made under Seveso 3 into the UK. However, that means now that these frameworks have the potential to drift over time. And if you are operating in the European Union as well as the UK, that would be something to bear in mind. Both the UK implementation of CLP and the EU's implementation are now separate, so you will have the same watching to do on that side. And it essentially means that you've got two rule books. But at the moment, there is no great difference. So it should be relatively easy, but bear in mind that these frameworks may drift over time. So we compiled a list of mistakes that we've seen from both new COMAH sites and previous ones as well, where they've had some changes, for example. Treating aggregation as optional. That was only looking at the worst case quantities rather than adding together contributions from a number of different compounds under the same category. Missing transient inventory. This one is tricky. As I said, sometimes a single delivery can take you over a particular threshold. A lot of companies try to manage them separately, but that won't wash. If you're managing two geographically separate inventories as one inventory, then really you should be counting those together. Assuming that your status is permanent. If your inventory change, if the tier status may be reviewed, and that goes up as well as down as well. If your inventory goes down, it may reduce the burden, but you still need to inform the regulator of that reduction in burden, because it means they need to change their approach as well. And looking at outdated CLP classifications as well. So I've seen a lot of this in the past, where the MSDS that I've asked to have a look at is dog-eared and torn and about 10 years old. These things do change from time to time, or they can change. And the very fact that they can change means that you should really be looking at the most up-to-date versions. Gradually over the years, we've noticed things where no data was very common to see on a safety data sheet. It's much less common now. So as far as section 1's concerned, that's how COMAH sits in relation to Seveso 2. It's reviewed from time to time, not now as a result of changes in EU legislation, but we are good in this country at updating these rules as and when lessons become learned. So what you need to remember is these four things. It's quantity and category test. That's regulation 3. Do you qualify, and under what circumstances do you qualify? Aggregation is a failure point. It is a calculation to do, and that requires looking at the CLP regulations to get the various categories. COMAH and Seveso 3 share DNA. It's a good way of thinking it. They're now cousins as opposed to siblings. I must remember that's quite good. Yes, cousins rather than siblings, and they will diverge over time, I have no doubt. So we can't assume that they're going to move in parallel. And it's a live process. It's not just a one-off. So most companies will have to at least keep a weather eye on how things are changing as time goes forward. So that's the most boring bit and done with. We'll have a look now at what goes into your major accident prevention policy, what your safety management system needs to demonstrate. The main things are found in Schedule 2 of the for the elements of a safety management system. This ties in very well with the post-Buncefield Process Safety Leadership Group recommendations as to where process safety should be focused. Competence, change, and audit as your means of proving that your safety management system is working as it should. So we'll say a little bit more about that. When you are inspected, it's not going to be practicable for them to look at every single thing. So they will typically take an example of a major accident that you have been able to identify through your hazard analysis and trace them. And that means they're going to go through whatever risk assessment that was done from the very outset of what are the hazards that we've got, what can go wrong, what are the systems that we've got to prevent that from happening, so the control measures. Have we got a good and defensible estimate of what the consequences might be? And therefore, are you in a position that you have mitigated that major accident to as low as reasonably practicable? Not only that, but what are you going to do in future to reduce the risk still further? Because we have this principle in the UK of continual improvement, and it's a good one because we're a small, crowded island, and there's no such thing as zero risk. But the best thing we can do is to improve through technology and reducing costs year on year to get that risk down. So existence is not the same as use. If you have a document, it might exist, but it might not be the one that's used. It might be never used. And we've seen examples of this in the past as well. If you think to Texas City in 2005, there was a procedure for restarting the raffinate splitter, the unit that was overfilled. There was a procedure for that, but it was out of date and known to be so by management as well. So the very fact that it exists does not prove its use. Interviews, inspectors will very often have conversations with operators and supervisors. We recommend that management for the company do too. It's a very good way to learn. It's a very good way to demonstrate that process safety is seen as important at the top of the shop as well. And findings, where policy language is generic. So I'm not suggesting you all go off and get ChatGPT to write your major accident prevention policy, because you will get generics in those cases. So it has to be tailored to your own set of circumstances, the way you operate in your particular suite of major accident potential. So that's what the inspectors are going to be looking for. The two documents, the two main documents, the upper tier and the lower tier document, the SMS and the major accident prevention policy, have different roles. So I said that the MAPP was relatively short. A board level statement of intent and principles sets the standard that the company is expected to meet, signed off by senior management. So it's supposed to demonstrate that management is committed to everything that follows. And it should be current as well. So it should be reviewed and revised. If it's based on outdated assessment of major accident potential, it's not going to cut mustard. The safety management system, we want to be assured, we need to demonstrate that the operating system delivers what has been said here in practice. It must cover the organization, the identification of hazards, how you control your operations, how you manage change, how you plan for emergencies, how you monitor and audit. This is essentially a risk assessment. What can go wrong? What are the safeguards to prevent, to control and mitigate it? And what are you going to do about it? And how do you assure yourselves that they're working properly? It's exactly the same as any risk assessment that you do. There's nothing new under the sun when it comes to these things, really. Proportionation is not a word, but it must be proportionate to the hazards and the complexity of the site. If you've got much larger potential, more complication going on, high temperatures and pressures, difficult to handle substances, that kind of control that you've got, that kind of hazard identification, that kind of risk assessment must be more rigorous. It stands to reason. If you're processing small amounts of lukewarm water, it doesn't have to be as rigorous, and lower quantities of control will be appropriate. But that proportion is where a lot of inspectors spend a lot of their time, evaluating that proportion and making sure that it's appropriate. So for your major accident prevention policy, the real thing to get in is that your statements are not just aspirational language. They must be able to be demonstrated and verified. So you need the backing to say, yes, we have this policy, and yes, it's followed, and here is the suite of signatures to say that it's been read every time we've had to use it. The authority to sign must be at a level with genuine power and genuine understanding as well. It's one thing to sign it. It's a different thing to be the receipt of things like audit reports that say you're not performing well on process safety, or that you need additional resource to carry out something under process safety, those kind of things as well. So it's board level commitment, but it's board level understanding as well, and therefore not delegated. It must be representative of your site, not just a generic corporate template, and it must be traceable. So it must contain references to the safety management system elements that actually deliver on those commitments. And therefore, the regulator can go and check. They can see that the document is current, up to date, reviewed, and the quality that goes behind that as well. So there is a paper trail trap that goes with this, and you don't want to fall into it. A file proves existence, not that the described activity happened or happened competently. The evidence must be questionable. Well, not questionable, it must be able to submit itself for questioning, otherwise it can't be defended. And that's the trail of who can answer, who did this, when, and against what standard, and what is the proof that goes with that. So there is a classic gap, and we have seen this as well. Quite a few clients actually, but procedures updated after an audit finding with no evidence that the change was communicated or trained out. So it was viewed at this point as being a paper exercise rather than a safety critical element, which it really should have been treated as. So inspectors know this happens. They've had ample experience of it happening. And so they probe this deliberately. We have a procedure for that. They will ask, show me it working, show me the signatures, show me where it's stored on the filing system the last time it was accessed, and so on. In Schedule 2, therefore, these are the components of the safety management system which you must be able to demonstrate, and demonstrate as being effective. Now, again, this lines up very, very closely with the focus areas that have been identified by both the Centre for Chemical Process Safety and the Energy Institute when formulating a process safety management system. Just got two extra words to put on the front of this, but it does exactly the same thing. The organisation and its personnel, in particular the competence of those people within their roles and the responsibilities that they've been given. The quality, the rigor with which you've done the hazard identification and evaluation, because without that, you don't know how good your safety critical elements need to be in order to meet those hazards. How well you control under operation and abnormal operation as well. How well you manage change, whether change is identifiable, for example, an urgent change, a minor change, or a temporary change, all need to be discriminated out. Emergency planning and monitoring of performance and audit and review. Emergency planning, this is the mitigation bit as well. It is a requirement under COMAH that an on-site emergency plan needs to be formulated. And the assurance processes of the monitoring and review as well. This is assurance not only for the regulator, but for yourselves as well. And without it, you are unable to take the credit for having all the good controls that I'm sure you have. So you can think of the elements of controlling against major accidents as either preventing them, controlling a rate of release once you've got a problem going on, and the mitigation that goes afterwards. All of them interrupt the chain of events between having a loss of containment and somebody being hurt at the end of it, or reduce the potential for that. So if something does one of those jobs, you can consider it as being safety critical: prevention, control, and mitigation. Competence in management needs to be evidenced as well. So as a real test of a safety management system, can you show who is competent for carrying out these safety critical tasks, how it was assessed? And the reason for that is you may go on a training course, but that does not automatically translate into competence. So training is one thing, competence is the demonstration that the requirements have been met. This includes contractors as well. Shift workers, contractors can't just turn up with their own competency and then sit through what I assume these days is now a 20-minute video as they go through the induction process. And it must be traceable to the identified major accident hazards. Demonstration is one word, traceability is another word that I'm probably going to use more than its fair share. But being able to trace the safety systems, the safety critical elements that you've got, and in this case, we're talking about competency, to a specific major accident, is going to help the HSE enormously when it comes to evaluating your safety management system. Management of change was one of the elements that we cited there. How well does yours work? Now, when I'm doing training and when I'm with clients, I usually ask them, your management of change system, is it brilliant? Does it work well? Easy to use, relatively rapid? Nobody ever says yes to any of those questions. It's drawn out, it's difficult to get the people together, it goes through rounds of reviews, things like that, and you think, well, actually good, because that's the way it gives us confidence there that you're actually spending some time in evaluating things. So identify changes, first of all. It must capture all the changes that you're making. So being discriminatory between what is a minor or a like-for-like change, something that doesn't quite require the rigor, being judgmental in that sense is important, but also consider things like organizational change as well. So if a particular guy who knows how one particular reactor decides to leave, make sure that knowledge doesn't go out the door with him. The change must have a means of assessment, and in particular, because we're looking for traceability, we're looking for demonstration, it must be tied in again to your major accident hazards. Does it affect them? And that's what the HSE would be looking for. Authorised at a level matched risk to the level of risk for which the change is appropriate. So this might go quite far up the chain if it's significance, and it could affect major accident potential, because that's where we would hope the experience and understanding comes in, and critically, the understanding. Must be implemented and communicated. We've seen examples where management of change has not been effectively communicated and the major accident has been the result. And the example there that we usually give is Piper Alpha. And close out and verification. This is important as well, as it updates the performance. It makes some material change to the way that the hazards were originally evaluated, either increasing them or decreasing them. So that's important to do as well. It also shows that you've completed the circle, if you like. It shows that you're managing the process in a rigorous and professional way. Audit and review. This was one that I mentioned also, has been in section 2 of COMAH. Without audit and review, you can drift out of date with the other elements. They become less effective because you don't have the information. You might be one accident away from a missed inspection, for example. Independence matters. So it's a truism, I suppose, that the people least suited to doing the audit are the people being audited. It's why the police usually have independent people to come in and do it. But again, make it proportional to the level of risk that you're talking about. Visible action tracking to closure. Not just close status on a spreadsheet. Let's see what the actual recommendations and implementation of those were. By far and away, this is the bit I see most clients fall short on. We've got limited resources and limited time. We understand that, and it's going to be the area where least amount of effort is put in, but it's a useful thing to do. And management review at the end of it. And this comes back to something I mentioned earlier, somebody at board level with responsibility for process safety and with who is in a position to be able to understand what they're being asked to review as well. So your MAPP is going to set the commitment to managing your major accident. It's this high level statement of policy. You must be able to defend it through evidence, competency records, and so on. Must be proportionate to the major accidents that you're talking about, not generic, not something you got from an AI. Must reflect your hazards and the way you operate. You might operate better than everybody else. So make that a feature, not a bug. And you might operate worse than everybody else, in which case you're potentially misleading the regulator. So think about it and be honest about it. So my third section is the hazard identification, the risk assessment, and how you go about demonstrating that those risks are under control. And again, traceability and demonstration of the key things, but also this linking to the major accident scenarios that are named in your COMAH report. It is the risk assessment. It is your demonstration that your risks are as low as possible, reasonably practicable even. So offshore, we have things called safety cases. This is essentially what a COMAH report is. So I've used the same nomenclature there, but they do exactly the same things. It is an argument, it's not a description. So an argument requires the evidence that goes with it. Your major accident policy is a description. Your safety management system is the argument that goes with it. They sit on 3 pillars: the identification of hazards, the risk assessment, and the demonstration of control. This is the middle bit of any risk assessment. What can go wrong? What are the systems to prevent it from happening? And what is the information that those are working as they should do? Each one of those depends on what goes before it. And that's the chain of events. That's what the regulator wants to see. Have you identified the major accident potential? How bad it can be? What the control measures specifically are against that major accident, and therefore can you demonstrate that they're working effectively? This is laid down in a safety report. There is an approved code of practice that goes for writing COMAH safety reports, but as I say, most companies now are well into their 3rd or 4th and 5th iteration of their COMAH safety reports and safety cases. And just as a sort of, it's not terribly technical, but if it reads well, but can't be traced to these site-specific evidences, it's going to be rejected and you're going to get more work to do as a result. It's simply what I said before. What you say must be tied in to the major accidents that you've been able to identify. There are any number of hazard identification techniques, and which one is appropriate is going to be a judgment call based on the consequences or the severity of the hazards that you're looking at So HAZOP is very often used because they exist, and they're a very good way of getting detail out. These two, the what ifs and the hazards, I prefer the hazard because it's generally designed to get you the major accident hazards first. So then less resource intensive, but they get you that information out reasonably quickly. So I like hazards for writing COMAH safety reports, and generally they're a lot easier to go through subsequently for the regulator as well. They are broader, but they give you this opportunity for early identification of not only the major accident when it's operating, but also before the design's fixed as well. Checklists and standards review and learning from others as well. It is a requirement under the COMAH regs now that a past accident review is carried out, and that's not only from your own experience as well, it's from the experience of others working in your sector. So what we need to do is to take the hazard to the major accident scenario. Not every hazard will qualify, but there must be a credible chain of events. An initiating event, its escalation, the loss of containment, the consequence as well. So it's no use saying that you've got a loss of containment of a flammable liquid and leaving it at that. We have to ignite it, we have to have people in the area, and it must be tailored to your specific sets of circumstances. For example, you carry all your flammable material next to the canteen, for example, as opposed to an open field, which is not going to hurt anybody. It makes a difference. So it must be tied to your particular set of peculiarities. It should be a reasonably foreseeable worst case as well. And you must revisit these periodically as well, because change happens. It could be change from within. People may leave, etc. Could be change imposed on you from outside. Domino sites might be one. New lessons learned from adjacent industries, or it could be the fact that a school or a hospital has been built next door. That changes your risk profile, and therefore you need to do more in order to demonstrate that your risks are as low as reasonably practicable. So we do this through this process of risk assessment. We've identified what the hazards are, and we have means of doing this. Qualitative, first of all, a starter. They're quick and easy to use, so I'm sure that you will have all seen a risk matrix in the past. There is one published by HSE in its document R2P2, Reducing Risk Protection People. LOPA, Layer of Protection Analysis, puts some numbers together based on the event frequency, the probabilities of failure of demand of your control measures, and compares that with what is considered tolerable to see if you've made that. And that allows you to say, well, what more can we do and why haven't we done it? Quantitative risk assessment supports the decision. So with the numbers now, we're getting into much more detailed analysis. And human factors as well. So a lot of plants run using operators being now considered safety critical to the way that a plant operates as well, and rightly so. So analysing human performance, what people are being asked to do, the nature of the job, the nature of the organisation, and the nature of the people themselves, how those factors all interact together to make the potential for a loss containment much less likely. So demonstration again, how you demonstrate that you've got adequate control. If you've got a claim for a particular measure, it must be maintained, it must exist, and it must function according to the design that you've given it. So I shall say a little bit more about the criticality of having the correct design in a little while. But this is what you're going to be judged against, whether your risks are as low as reasonably practicable. You do this by asking two questions. What more can we do? Why haven't we done it? That requires a cost-benefit analysis. And your goal is to get to a point where any further risk reduction is grossly disproportionate in terms of expense to the benefit that it brings. So you spend £1 million to reduce a cut finger, it's no longer justifiable in terms of the risk reduction it generates. How failure would be tolerated, managed, detected, etc. Should be shown as well. And often failures occurs because that exists on paper, the control, but its performance cannot be evidenced. That means you cannot take the credit for it. And it sounds like a thoroughly practical and physical explanation, but it isn't. You're just not allowed to take the credit for it, regardless of the quality of the design. We've seen too many examples where that hasn't happened. Bunsfield, with its high-level switch on the top that had been installed wrongly. It was there, the design was right, but it wasn't installed correctly and never functioned in the way that it was supposed to as well. So we know about these things now. You need to be able to demonstrate that adequate control is there and that you can evidence it as well. So together, these make up our safety critical elements. You can think of them in terms of P's, if you like: the plant, the processes, the procedures, and the people, where failure could either cause a significant accident or where they act as a safety critical element against a major accident as well. So it's a handy little aid memoir. Think in terms of those P's. Hardware and human, relief systems, etc., as well as permitry. So those are going to be plant items. Those are going to be processes or procedural items. Not everything qualifies. And this is where we do have a good example of a company that was a little overzealous in what it considered safety critical, in that virtually everything they owned, they said, well, that's got to be safety critical, and thought they'd done a good job. Unfortunately, the regulator quite rightly said, well, okay, if you're going to claim that this is safety critical, demonstrate to us that you're managing it to that effect. So you've got to look at this with a certain amount of intelligence and judgment as well. It means that you can then focus effort on the things that are really going to matter, that are really going to do you some good. And traceable identification. Again, traceability back to the major accident scenario that it is meant to control. The risk evaluation techniques that I described on the previous slide is the way that you do this. You can cite then a particular control measure of whatever type and trace it directly back to the major accident scenario. You've then got a lovely story to tell. It's more poetry than prose, that you've got your hazards, you've correctly identified what the consequences are, you've got all these neatly labeled out safety critical elements, strength and depth of different types at different levels of prevention, control, and mitigation. Therefore, you're in a much stronger position of being able to demonstrate that residual risk is as low as reasonably practicable. So for your safety critical elements, there are 4 properties. But, they must be functional. That function must be defined. It must be a safety function. They must be available, reliable, and survivable as well. So they must work when they're meant to work, and that includes when accidents are going on. Does it do what it's meant to do? Is it there when it's needed? Again, Bunsfield with a high-level switch at the top of a tank that was overfilled. 300 tons of unleaded petrol went into the bund, found a source of ignition, and there was the largest peacetime explosion in the UK since 1974. Performance standards translate into inspection, testing, and maintenance regime. So are these sectioned out in your what do they call them? Your asset management system as being safety critical, and does that translate effectively into the testing and maintenance regime? Again, in Texas City, for example, there was a high level switch on the column. There was a level transmitter as well, but they'd already circumvented that, and they knew that this level switch did not work. And the work order kept going on, and they never got fixed. So deviations from this should trigger a response as well, a defined response, and not a silent toleration of a standard not being met. So you need to do something about it if those are the messages that are coming back up. So there is a very good tool for demonstrating all this, the bow tie drawing. So it's a good way of visualizing what's going on. It shows the barriers that you've got to prevent the loss of containment in the first place on the left-hand side, and how you mitigate the loss of containment on the right-hand side. But this is the key thing. It's how legible it is as well. They're very useful little tools. You could put them up next to a tanker filling operation, for example, and really demonstrate to the operators why we ask them to do what we're asking them to do. So I shan't spend too much time on this. I've covered these bits. Connected argument, demonstration means evidence. Your safety critical elements and visual aids help to do that as well. And the reason I've only got 5 minutes left. It's funny, it's dry as it was, you don't have to get lost in the detail when you start going. So we'll move on to linking regulation to operational controls and engineering controls as well. So this is again how you demonstrate what is happening. The regulation sets what, how you do it is achieved through your controls. And we want this clean, traceable line, this demonstration, this prose, if you like, that tells a story that you are managing your risks as they should be. The design basis must be traceable. I said I'd come back to design. So these safety critical devices should be engineered and traced to the scenario for which the performance standard for which it was sized. So it is tied into a specific scenario that you can now demonstrate. It is that it's capable of being controlled because of that. Must survive modification without changing that design basis. Why this spec matters just as much as does it work as well. So you maintain this credible link to the original scenario, and just keep an eye on aging plant and obsolescence. Things don't always work as well as they should, and our expectations change as well over time. So our operational controls, our procedures, and safety critical elements are tested hardest when things go wrong, self-evidently. Permits and isolation procedures are usually the things that we see most difficulty with. They're the hardest ones to get right because they interact with so many other things, operating plant, for example. They must be validated with the users. Texas City, the procedures were known to be out of date by management. They were known to be out of date by the operators as well. And when they were updated, they didn't get the operators' input, which is a vital thing to do because the operators understand how plant actually works in practice rather than how it theoretically worked when it was originally designed. And roles and accountability. Do people know what their responsibilities are under the process safety management system? Named ownership. Every safety critical control needs somebody who is accountable for its performance. That ownership must survive change as well. So if that person leaves, somebody else takes over, they must have the same level of knowledge. It must be visible and must be clarity on who owns various assets, especially when contractors or tenants share a site. So it's the boundary, it's the interfaces that get you. And because you have contractors on site, it's the inspection and the testing regimes that are critical for that. So they must be derived, and they must be derived from things like performance standards. They must be tested under representative test conditions, not simply forcing a signal on it, but actually seeing that a pressure switch operates at a particular pressure as well. It's the actual demand rather than a contrived demand that's going to be important. And a leading inspection finding here was that missed or overdue tests on safety critical elements are among the most common and the most serious findings that they've found. So this is you can mitigate against this to a certain extent because schedules slip. There's no doubt about it, but you can get recovery and have a procedure for how you recover from those. There's a technical term for such things which name escapes me at the moment. But these are the kind of things that the regulator has spotted in the past, and where the COMAH safety reports have slipped. So I'm more or less on the button of 4. I'm going to stop it at that point, and thank you very much indeed for your attention. It's one of those subjects that you could, I mean, I could talk to you for a day or so, and perhaps get half of it covered, but these are the important bits. What we do for you, if there's anything specific that you would like any feedback on, then please, by all means, drop us a line. I know that Joe's been listening in on the webinar, and I believe he's been taking questions as we've been going as well. But you've got our contact details. Please drop us a line, and we'll endeavour to do whatever we can. But in the meantime, enjoy the rest of your afternoon. The sun's gone in, but still nice and warm out there. But thanks very much for your time. I do appreciate it. Take care. Thanks. Bye.